Now, coming to the preparation of alcohol, or we'll start alcohol. So, what are alcohols, so to say? Alcohols are hydroxy derivatives of alkanes. Hydroxy derivatives of alkanes. Hydroxy means OH. Got it? So, from that is alkanes, RH, if you add OH, alright? So, you write the reaction in this way. This is not an actual reaction of preparation of alcohol. Just to explain you, I am telling you. Don't think this is one of the methods for the preparation of alcohol. Just to explain the definition. So, you will add OH and you will remove H. What you will get? You will get ROH. Understood? So, this is nothing but alcohol, so to say. It's a hydroxy derivatives of alkanes. The functional group of alcohol is OH. The functional group. I can write in this way also. That is, OH is the functional group of alcohols and it is called as hydroxy derivatives. Now, based upon it, we are having different types of alcohol starting from methanol, CH3OH. Then after that, you add CH2 group. You will be having ethanol, C2H5OH. Then you add another CH2 group. Got it? Homologous series, na? You know it. You will be getting C3H7OH, propanol. Similarly, you will get butanol, pentanol. You go on adding CH2 group, you will be getting the respective or the successive, what you can say, alcohols, you will be getting it. You go on adding CH2 group. First methanol, CH3OH, then ethanol, then propanol, then butanol, then pentanol. It goes on in this particular manner. So, these are called as monohydroxy, what you can say, alcohol. Monohydroxy. Why monohydroxy? Because it contains one OH group. One OH group. For example, that is CH3OH. What I said? Methyl alcohol, common name, and IUPAC name methanol. When I say C2H5OH, what I said? Ethanol is a IUPAC name, common name is ethyl alcohol. In this way it goes on. So, what you find is that we are having just one OH group. So, it is called as monohydric alcohol or monohydroxy derivatives of alkanes, we can say that. What is monohydric alcohol having one OH group? Similarly, if you are having two OH group, it is said to be dihydric alcohol. Two OH group means, let us say CH2OH, CH2OH. Let me give an example. So, this is known as ethane, 2 carbon is eth, carbon-carbon single bond is ane, ethane 1,2-diol. How it is 1,2? First and second carbon atom. First carbon atom 1 OH, second carbon atom another OH. So, ethane 1,2-diol, or the common name is ethylene glycol. The common name is ethylene glycol. We can say that. Clear? Similarly, if you are having three OH groups, CH2OH, single bond CHOH, single bond CH2OH. So 1, 2, 3. Alright, 1, 2, 3. So that is root word is prop. Then it is N, carbon-carbon single bond is N. So propane 1, 2, 3. 1, 2, 3 triol. Propane 1, 2, 3 triol. We can say that. Next, we can also say the common name as, you heard it earlier, glycerol or glycerine. We can say that. Alright, glycerol or glycerine. In this way, we can have monohydric alcohol. Don't think just one we are having the compound. We are having many compounds in it. Just to give an example, to explain you, I gave one example. So, it is monohydric, dihydric and trihydric alcohol, we get it. Fine. Now, the source of alcohol, we are not getting in the nature alcohol. We are generally getting it by the fermentation of, what you can say, the sugar. The fermentation of sugar, the fermentation of molasses. When you do go for fermentation reaction, then you get alcohol. Alright. That is, when you go for fermentation reactions of sugar, the molasses means good, we can say that. Clear. We are also getting it from cracking of petroleum. When petroleum undergoes combustion in insufficient air, which is called as pyrolysis. Under pyrolysis or under cracking of petroleum, we can also get alcohol. That is methanol, ethanol, we can say that we will be getting it as a byproduct. Clear? We can also prepare it from ethers, we can say that. That is ethers, I am saying, sorry, ethene we can prepare from ethene, not ether, sorry. Ethene we can prepare, that is alcohol. So, in this way we will be seeing it, this particular one. Next, we will come to the preparations of alcohol. I was talking to you preparations only. So, in words I was talking to you. Now, I will tell you the equations. So, We can prepare from alkyl halide. For example, let us say C2H5Cl plus NaOH aqueous, either NaOH or KOH, anything you can take it. C2H5Cl plus NaOH aqueous, what it will be? It will be C2H5OH plus NaCl. Now why it is so? Because you know sodium is positive and OH is negative. Similarly, Cl is negative and carbon is positive. So this positive goes with this negative. See here, C2H5 goes with OH, positive, negative. And this positive and negative goes Na plus Cl minus. Always like charges repels, unlike charges attracts. So this is unlike charges. So it forms C2H5OH and NaCl. You can take KOH also here. You can take any alkyl halides, you can take it. Any alkyl halides. You can take CH3Cl, you can take CH3Br, you can take C2H5I, any alkyl halides you can take it. Corresponding alcohol you will be getting it. Corresponding alcohol you will be getting it. Clear? Suppose if you take a C2H5Br plus KOH, you will be getting C2H5OH plus KBr. Suppose if you take a CH3I plus NaOH, you will be getting CH3OH plus NaI. In this way, corresponding alcohol you will be getting it. Now, next is you can prepare from ethene. We can prepare it. Like suppose if you take ethene C2H4 plus H2SO4, you write it in this way, HSO4, it will be easy for you to write the reactions. Then what I will be getting it? I will be getting, that is, it should be conc H2SO4. Alright. Now the temperature should be 80 degrees centigrade and under 30 atmospheric pressure. The condition should be 80 degrees centigrade and 30 atmospheric pressure. I said you earlier also, now also I am saying you. Organic chemistry condition has to be mentioned, otherwise no marks will be given to you. Mind it. Condition has to be there. So in this way, what you will be getting it? Now ethene, you already studied. It undergoes addition reactions. Alright? Ethene undergoes addition reactions. Ethene, it undergoes. So hence, this also will undergo addition reactions. So what it will be? It will be C2H5HSO4. C2H5HSO4. For that reason, I wrote it in this way. That H is being added here. The C2H5HSO4. Alright, if you write the structure, then it will be in this way. CH2 double bond CH2 plus HHSO4. So one H will be added here and HSO4 will be added here. So it is what? CH3 CH2 HSO4. Same thing this C2H5HSO4. Same thing this. Alright. Here this hydrogen is added and here HSO4 is being added. So hydrogen added means what it will be? CH3 and it will be CH2 HSO4. Same thing this. Ethyl hydrogen sulfate. We can say that. Ethyl hydrogen sulfate. So in this way, you will be getting ethyl hydrogen sulfate. Now, I don't want ethyl hydrogen sulfate, isn't it? So what I need to do is that I have to go for hydrolysis. C2H5HSO4 plus HOH, that is water. So what will happen? See here. This will react to form H2SO4 and what you got? C2H5OH. You got C2H5OH plus H2SO4. In this way you got ethyl alcohol. You got it. Clear? Now that is, you can write the reaction in this way also. Got it? Instead of writing in two steps, you can write in one step in this way also. CH2 double bond CH2 plus HOH in presence of H plus. H plus means what? Acidic medium. Acidic medium, because your sulfuric acid acts as a medium or a catalyst. We can say that. Yes. How can you say? We have taken sulfuric acid, we got it back. We took sulfuric acid here in the first step and we got it back in the second step. So it does not participate in the reaction. You can say that. So hence, for that reason, you can write H plus. H plus means what? Acidic medium. It is said to be. The medium has to be acidic. Why? Because then only water will dissociate into H plus and OH minus ions. Because pure water is a non-conductor of electricity. You know that. It does not dissociate into its ions. It's a covalent compound, pure water. Isn't it? So hence, in presence of acid only, it will dissociate. So H plus ion will come here to form CH3 and OH minus ion will come here to form CH2OH. So what you will be getting it? CH3, CH2OH. In this way also, you can write the reaction, so to say. Clear? Then I was saying you that we can go for fermentation reaction. Fermentation of alcohol, I was saying you. Alright, now in fermentation what we do is that, let us say sugar, C12H22O11 plus water. Same thing, we will go for hydrolysis. In presence of an enzyme. So here the enzyme that you will be taking it is, that is, we will get it from yeast, that particular enzymes, because we added yeast only to it. So what is that? That is nothing but known as invertase. We can say that. Invertase, we can say. The enzyme is. So what is going to happen? We are going to get C6H12O6 plus C6H12O6. One is glucose, another is fructose. They are the what you can say, they are the isomers. They have got the same molecular formula but different structural formula. C6H12O6 and C6H12O6. We can't write two C6H12O6. Why? Because these two are different compound. One is glucose, another is fructose. Alright, one is glucose, another is fructose. They are having the same molecular formula, but they have got different structural formula. So they are the isomers of each other. So in this way we are writing it. Now what you will do is that you will take glucose, C6H12O6. You will take another enzyme here that is known as zymase. We can take it. Alright. So in absence of oxygen, an anaerobic reaction is going to take place. What? In absence of oxygen, in presence of this enzyme that is zymase, they are the biocatalyst, you know? Enzymes, these enzymes are the biocatalyst. Alright, clear? So same thing, you are getting it from the yeast only, this particular one. This is a fermentation reaction to give you what? Alcohol and water. C2H5OH plus H2O. So that is two molecules of this plus 4 carbons, 6 carbons, sorry, carbon dioxide, CO2, 2 CO, because total 6 carbon has to be there. Here 6 carbon, so 4 plus 2, 6 carbon, correct. So in this way we get it, that is alcohol from fermentation reaction. So these are the different methods by which you can prepare alcohol, so to say. So alcohol is an inflammable liquid, remember it, inflammable volatile liquid and toxic in nature. Alright, methyl alcohol is not fit for consumption. Ethyl alcohol is fit for consumption, that too in not in large doses. In large doses it will lead to death, we can say that. And basically methyl alcohol, what you can say is that it is used as an industrial solvent. It is not used for drinking purposes, methyl alcohol. But ethyl alcohol can be used for drinking purposes but in small doses. Alright, clear? Now it is colorless liquid with a sharp, what you can say, or a characteristic pleasant odor depending upon the nature of the alcohol. It is soluble in water in all proportions, as well as in organic solvent. We can say that organic solvent like ether, benzene, toluene, all those things. We can say that. It's a good solvent. Remember it. It's a good solvent. See, it is very important, this particular sentence which I am saying you. For dissolving of oil, fat, then resins, it's a good solvent. Alright. So basically you know that for what you can say, washing of this winter clothes, we can say that we are using that is alcohol and all these things we are using it because it removes the oil and the grease which is being present in it. We are going for dry cleaning. That is called as dry cleaning because it is a good solvent for dissolving of oils, the fats and the resins, we can say that. And also inorganic solvent compounds like sulfur and phosphorus, we can say that, inorganic substances. Like sulfur and phosphorus, it dissolves. It's a good solvent. But remember this particular sentence is very important. Now, alcohol, you know that it undergoes oxidation reactions. Now, one simple oxidation reaction, you know that when any organic compound is heated in air, it gives you two products. What is that? Carbon dioxide and water. Any organic compound, it's heated. Alright, whether it's alcohol, alkene, alkyne, anything, any organic compound that is heated in air, it gives you two products, that is carbon dioxide and water. So here alcohol also, when you are heating in air, any alcohol, ethyl alcohol, methyl alcohol, it gives you carbon dioxide and water as the only two product. We can say that you must remember it always. Ethyl alcohol plus oxygen will give you CO2 and water. Methyl alcohol plus oxygen will give you CO2 and water. Alright, any organic compound, mind it, any organic compound, listen to it. Now next is you have learnt it that I have said you ethyl alcohol on oxidation. Alright, like C2H5OH on oxidation. Oxidation means it will give you innocent oxygen. From where you get it? From any oxidizing agent. I have discussed with you earlier. That is K2Cr2O7/H+, acidified K2Cr2O7 or acidified KMnO4 or concentrated nitric acid or dilute nitric acid. These are the oxidizing agent which will give you innocent oxygen. So alcohol will oxidize to give you what? Aldehyde. Always. Aldehyde is unstable product. It will further oxidize to give you, that is nothing but acid. Secondary product, I am not writing it here because it's a chain reaction. I am not writing the secondary product, it's a chain reaction. Alright, so in this way, ethyl alcohol to ethanol, ethanol to ethanoic acid. Or common name is acetaldehyde and this is your acetic acid. Okay, in this way, you can take any alcohol, it will be converted into aldehyde, aldehyde to acid. Remember it, don't forget this particular, it's very important. Any alcohol on oxidation gives aldehyde and aldehyde, It's an unstable product. It will further oxidize to give you a stable product, that is carboxylic acid. Now, next is C2H5OH. When it reacts with sodium, it will give you C2H5ONA and hydrogen gas is released. How do you know hydrogen gas is released? It burns off a glowing splinter with a pop sound. We can say that. So to balance it, 2, 2, 2, you just put it. That is sodium ethoxide. This one is. This is sodium ethoxide, we can say, and hydrogen gas is released. Alright, this also is a test for alcohols. We can say that the release of hydrogen gas, which burns off a glowing splinter with a pop sound. We can say that when it is treated with sodium or potassium. Potassium also you can take it here, no problem. Now, next is another important reaction, C2H5OH, when it is treated with acid, that is acetic acid. Alright, it's a reversible reaction, I will give it to you. And H2SO4 conc, concentrated sulfuric acid, which acts as a dehydrating agent. It will remove water. How? Here from H and here it is OH. So HH is removed. So what I am going to get it? CH3CO and here another O. And what I am going to get? C2H5 plus water. Alright. What is this compound? It is ethyl acetate. It is an ester. It is having a fruity smell. Good smell, a fruity smell. The formation of this smell only proves there is a test for alcohol. It is also a test for acid also. Alright, in acid also I will tell you. So in this way, this is known as ethyl acetate. Ethyl and this is acetate. And the IUPAC name will be ethyl ethanoate. 2 carbon, ethyl ethanoate. We can say the IUPAC name. And the common name is ethyl acetate. It's an ester. It is having a fruity smell, a good smell. We can say that. This also is a test for alcohols. We can say that. Here, concentrated sulfuric acid is taken as a dehydrating agent. It will remove water. For that reason, it's been taken. If you won't take concentrated sulfuric acid, reaction is not going to take place. Reaction is not going to take place in absence of concentrated sulfuric acid. And the reaction is reversible. Alright, this reaction is reversible. For that reason, once the reaction is started and water is being removed from it, then the reaction is carried out in forward direction only. Alright, what I said, the reaction is reversible, but you remove water from the site of the reaction. Then the reaction will be carried out in forward direction. It will no more be reversible. It will not be reversible in nature. We can say that. C2H5. It is properly I am writing it. Yeah, now it is okay. Now, next is if you heat, that is ethyl alcohol, C2H5OH. This I have said you in alkenes chapter. That is, if you take H2SO4 conc and heat it at a temperature of 160 to 170 degrees Celsius. Then water will be removed and you will get ethene, CH2 double bond CH2 plus water. You will get ethene. This is called as dehydration of alcohol. We can say that. Dehydration. See, removal of, that is water. Similarly, if the condition is changed, for that reason I am saying condition is very important. 2 molecules of alcohol you take, same H2SO4 conc, but the temperature is now 140 degrees Celsius instead of 160 to 170 degree. Now it is 140, it is lowered. And in presence of 2 alcohol, what I will be getting it? I will be getting C2H5 O C2H5 plus water. This also is dehydration. Dehydration is removal of water. This also is dehydration, but it gives you ether. Diethyl ether or ethoxyethane. Diethyl ether or ethoxyethane, and this gives you alkene. See the condition. When condition changes, the product also changes. When the condition is changing, the product also is changing. We can say. For that reason, I am saying condition is very important. Alright. Now next is another reaction. You may write it down. I will tell you. I don't have the space here. You may write it down. C2H5OH plus PCl3. C2H5OH plus PCl3 will give you C2H5Cl plus H3PO3. C2H5Cl plus H3PO3, that is phosphorus acid. Correct? C2H5OH plus PCl3 will give you C2H5Cl plus H3PO3. You can balance it this reaction. So this is about your alcohol. We can say uses. I have already said you can see that it is used for the preparation of that is acetaldehyde, acetic acid. It is used for the dissolving of fats, resins, gums, and all those things. We can say in the what you can say low freezing. It is liquid having a low freezing point. We can say that. Then I said spurious alcohol. I said that methyl alcohol, when it is mixed with ethyl alcohol as an impurities. When ethyl alcohol contains methyl alcohol as an impurities, it is called as spurious alcohol or illicit liquor. It is not fit for consumption. जिसको हिंदी में बोलते हैं ना जहरीला शराब, जिसको बोला जाता है हिंदी में. Alright, so that is called as illicit liquor or spurious alcohol. We can say that when ethyl alcohol contains methyl alcohol as an impurities. Alright, clear? So that is not fit for consumption. That is not at all fit because methyl alcohol is used as an industrial solvent. Methyl, don't get confused. methyl, methyl alcohol. It is used as an industrial solvent, so to say. So methylated spirit or alcohol is when ethyl alcohol contains 5% methyl alcohol. It is termed as methylated spirit. And denatured alcohol is ethyl alcohol containing pyridine or copper sulfate as an impurities, which is also not fit for consumption. Which is used as a industrial solvent. So knowingly in ethyl alcohol we are adding pyridine and copper sulfate as an industrial solvent. So that is called as denatured alcohol, which is not fit for consumption. Similarly, methylated spirit also containing methyl alcohol as an impurities in ethyl alcohol. Alright, 5%, that is called as methylated spirit. So that is not at all fit for consumption, remember it. Alright, so these are all called spurious alcohol or illicit liquor, all we can say that. Thank you.